Record, so everyone be nice. Okay. First period called something called the swooshy that we're going to talk about later. So third period called dubbed the plop down. First period dubbed the swooshy. So you guys have to come up with something, okay, for this lesson. And here it is. What we're going to do is we're going to solve logarithmic equations. And solving a logarithmic equation looks scarier than it actually is. So when you look at that, the question you ask yourself is, what do you do first? And the thing that you do first is what's the mathematical term is called like exponentiate, or basically just change from log form into exponential form. So first period called that swooshing. So basically take the 3, raise it to the power of 2, and you get back 4x minus 7. So that's what you do first. So we call that 3 squared is equal to 4x minus 7. Then all of a sudden, this big, scary, nasty logarithmic equation, just by changing it to exponential form, or exposutiating, as they called it, turns into a real easy problem. So 3 squared is 9 is equal to 4x minus 7. So if I'm going to solve this thing for x, I'm going to add 7 to both sides. So I'm going to get 16 is equal to 4x. So dividing by 4, of course, I'm going to get x is equal to 4. Pretty basic stuff. What do you think about that? That's not too bad, right? Now, again, what was the first thing you learned how to check an answer was correct back in the day? What did they teach you how to do? Work backwards. What do you mean by that? Plug it in, right? So let's take the most basic of things, right? So let's check.
Wait a minute. Hold up. Wait, where's that 3 going? They drew arrows and it's going to the 2, but the 2 is going to the 4x.
Yeah, 3 to the second power equals the 4x minus 7. That's exponentiating.
I know. Where's the 2 going? Yeah, that's what he said. Where's the 2 going? It's just like a fat game of cat and mouse. I know it's 3 squared.
This is like 2 the equals.
Oh, yeah, okay. Yeah, I thought that was like another 2 the.
How's that? So 3 to the equals that stuff. Does that make sense now that I wrote it in there? Okay. So how do we check this? Well, we're going to check to see that log base 3 of 4 times 4 minus 7 is indeed 2. All right, so if we take log base 3, well, 4 times 4 is 16. 16 minus 7 is 9 equals 2. So is it true that 3 squared gives you back 9? Yeah. Yes, of course, 3 squared is 9. So that means we did it correct. Now, you do not have to check every single time, but I wanted to demonstrate how you do check. And the reason is because sometimes we're going to have solutions that don't fit the entire problem that we're looking at. All right, so what do you think about first box? You guys are 1, 2, or 3? You guys are 3? You guys can do that all by your own? All right. All right, let's do number 2 here. I've got 2 times the log base 5 of x is equal to log base 5 of 9. Okay, first things first. What do you notice that's different about the first one that we did? There's logs on both sides. What else? There's a coefficient in front. There's a 2 in front. All your answers are correct. Yes, sir. They do have the same base. That's good news for us. If they didn't have the same base, we actually couldn't solve this thing. It'd be totally weird. Right? We have to use change of base formula and all kinds of things. So our bases are going to be lining up the same. All right, so first things first. Where did this 2 come from? Yeah, it came from up there, right? So I could write down log base 5 of x squared is equal to log base 5 of 9. Now you'll see on the left-hand side the notes I've written to you that there are 2 ways to solve this. I'm going to present both ways. One way is significantly shorter than the other way, but I'm sure that's the way you'll choose to do it. But I want to present the non-believers the other way, okay? So here we go. So I got 2 ways that I'm going to show you. I'm sure you guys will figure it out. If I give you log base 5 of x squared is equal to log base 5 of 9. Mr. Brem in the back said the bases were the same, and that is totally true, and that needs to be important. We have log base 5 of x. So that's what this means. Those need to be the same. And in this case, they are. If they are the same, okay, what we can do, we're allowed to do this. X squared is equal to 9. Whoa. Exactly. For all you non-believers, I'm about to prove it to you over in column 2. But I'm pretty sure everyone in this room can solve that x must be equal to the plus or minus square root of 9. So that leaves me with 2 answers, right? X is equal to 3 or negative 3. And we'll talk about that in just a second. You okay with that side? All right, now, for the people who were like, wait a minute, I'm sure you did something illegal. You can't just say all of a sudden x squared is 9. Here's like by way of a short demonstration of how we got to that point, right? So let's start in the same spot. Log base 5 of x squared is equal to log base 5 of 9. Okay, think algebra. If you want to solve for x, what would you do? You'd get everything to one side, and you'd solve for x, right? Okay, so let's condense this log, right? So log base 5 of x squared minus log base 5 of 9 is equal to 0. Is everyone okay with that algebraic step? Yeah. Okay. Now, notice that we are subtracting two logs. I gave the answer away there. So how do we condense them? Yeah, we are subtracting, but we condense them through division. So here's what I have. Log base 5 of x squared over 9 is now equal to 0. Okay, so far, I have not yet gotten rid of that logarithm. All right? But does anyone tell me what the next step should be? Yeah, exponentiate, right? So take 5, raise it to the power of 0. It should give you back this stuff. So 5 to the 0 power is equal to x squared divided by 9. So take a moment, make sure I've done everything legal so far. You with me on that? All right, great. How much is 5 to the 0? Yeah, 1 is equal to x squared divided by 9. And then, wouldn't we multiply both sides by 9? So, oh my gosh. Wait a minute. That's what I got right there. So, you like the second way? I'm so glad you like the second way. I kind of like the second way too. There's definitely more stuff going on there. I definitely have a deeper knowledge, right? Well, it turns out if you have log base same equals log base the same, you can just go ahead and take the actual logarithm out and produce the answer. However, there is something that I want to talk to you about. That one of these answers is not going to work. 3 or negative 3. Which one do you think it is? The negative 3. Now, I'm totally leading you on to that question, and I know that. The reason negative 3 is not going to work is for the following reason, so just follow back with me. If you go back to the original problem, and I take a negative 3 and I plug it right in for x, I'm taking 2 log base 5 of negative 3. Am I allowed to do that? Yes or no? Why or why not? No, probably because of the way I asked the question. Now, why? Yeah, what do you think?
Because a over the x can't be a negative number.
That's right. Do you remember? Don't forget the domain, all right? The domain of log base a of x. The x part has to be greater than 0. So if when you go back and you check and you produce an answer that's less than 0 for this x part, you have to remember there's a domain error there. So this negative 3 is what we call an extraneous solution. It has a silly name. The book is going to have you do some problems and say, all right, solve the logarithm and check for extraneous solutions. That's what they mean. An extraneous solution is a solution that is produced through no faulty algebra, but yet doesn't fit the problem when you go back and check. So like we came up with the 3 and the negative 3. All right, how you guys feeling about that? Good? Okay, cool. And then we're done. Another problem that uses that uses it. All right, here we go. Big funky thing here. All right, let's try and solve log base 4 of x plus 3 plus log base 4 of 2 minus x is equal to 1. I like the drive though, I gotta say. Okay, how about this? We're first noticing that we have an addition sign here. So how do we condense the logarithms? Multiplication. So we're going to have log base 4 of x plus 3 times 2 minus x equals 1. What?
It's 2 minus x, not x minus 2.
That's not, I know, man. That's the switcheroo. Yeah. Okay, so we condense through multiplication. Condense by multiplication. Okay. I should actually write the word out, multiplication. Okay, now what we're going to do is we're going to FOIL that inside part there and get log base 4 of, let's see here. Or actually, what we can do now is we can exponentiate this thing. So we can say 4 to the 1 is equal to this stuff. So 4 to the first is equal to x plus 3 times 2 minus x. Who did that? Who got that far? Yeah, like good. You got it? All right, so what is 4 to the first? Well, that's just 4 equals. Now let's use FOIL here. What's x times 2? 2x. Outer is negative x squared. Inner is positive 6. And then last is negative 3x. Is that right? Check my work. Did I get that right? Yeah. Okay. So I used FOIL there. All right. Then I'm going to combine everything like terms here. So I get to 4 is equal to, let's see here. How about negative x squared minus x plus 6? Cool with that part? All right, good. Now 0 will be negative x squared minus x plus 2. What did I do? I subtracted the 4. Now, watch this trick. 0 equals x squared plus x minus 2. What did I do? Yeah, multiply or divide by negative 1, right? Multiply both sides by negative 1, right? Just because I want positive exponents there. That's what I did. So I like having this divide so I can actually write on both sides and tell you what I did. Okay, now what do I have? What type of equation is this? It's a polynomial quadratic equation, right? And I can solve quadratics a number of ways. The first way is factoring. Will this thing factor? It sure will. Look, I'm almost done because the next thing's coming up. So 0 has to be, how do I do this? Maybe x and nope. X plus 2, x minus 1. Let's see. Yes. Nice job. Correct. Now, if I have a number times a number, so don't forget, right? I've got a number times a number equals 0. How do I get myself out of that? The 0 product property, right? The 0 product property says that you can just say, okay, x plus 2 is 0 or x minus 1 is 0. So x is negative 2 or x is 1. Those are two solutions there. Now, to be completely thorough, we need to check for what? So we have two answers here, negative 2 and 1. Now, just because an answer is negative doesn't necessarily mean that the answer is extraneous. Watch. If I plug a negative 2 right there, what's negative 2 plus 3? 1. And I'm taking the log base 4 of 1. Is that in the domain? Yeah. It sure is. What if I take a negative 2 and I plug it right there? I get 4, because 2 minus negative 2 is 4. Log base 4 of 4 is also legitimate. So I can have a negative 2. Now, can I have this positive 1? I'm sure I can. If I plug a 1 in here, I get 4. If I plug a 1 in there, I get 1. And both of those are legal, so my two answers stand at negative 2 and 1. Question? Yes. Okay, who remembers what the MAFE is? What does the MAFE stand for? Oh my God, yeah. The most amazing fact ever. Okay, great. Now you guys know what the acronym means, but what does it actually say? What does it actually say? Yeah, we got that part. What does it actually say mathematically? It's an if-then statement, right? Okay, help me out.
Right here.
All right.
A to the x equals a to the y, then x equals y.
There you go. Then x equals y. Now this a has to be greater than 0, but a cannot be 1. All right? It's got to be greater than 0, but not equal to 1 in this particular case. Otherwise, that fact does not actually work. So you've got a stipulation over there. So remember that part. All right? All right, great. So how do we use the most amazing fact ever? Well, in this case, you could probably just look at it and see. But let me give you the example of how the book wants you to solve this. If you have 3 to the x plus 1, the idea is to change 81 into a base of 3 so that you can implore. Implore? No, that's not the word. What's the word I'm looking for? Imply? Implore? Explore and imply? Yeah. Anyways, 3 to the 4th. There. I just stick to the math, not the words. Okay. Nah, 3 to the 4th. Yeah, you got 3, 9, 27, and then 81. So if 3 to the x plus 1 is equal to 3 to the 4, then according to the most amazing fact ever, I can say that x plus 1 is equal to 4, which implies that x has to be 3. Now, you could have just figured that out because if you knew ahead of time that 3 to the 4th is 81, then you need a 3 there. But other problems get more complicated, and you want to be able to change the base. All right, so here's what we did. Quick recap, starting at the top. We solved log equations, sort of like a basic one here, by exponentiating, checking it, solving another one, exponentiating, checking it. We had an extraneous solution. And then we kind of had a harder problem where we had to do a little bit more work. We had to do factoring, condensing, and checked, and we could have both solutions. We used the most amazing fact ever, and then we can solve those down there. All right, you guys feel pretty good about that? All right.